So some more similar shapes, and today we're going to do some things called frustums. I used to call them frustrums. I didn't realise there's no extra R in there. It is just a frustum. We'll come to that in a minute. Let's first of all, we need to remind ourselves of another skill, which is doing area of a circle. Remember, circumference is pi times diameter, but what is area? Give your answer in terms of pi, please. I don't want to see any decimals in these, just in terms of pi. That should make things easier. Oh, actually, there will be, sorry, they're saying no decimals. There will be some kind of decimal on this one. But anyway, area of the circle, write your answer in terms of pi with your units, unpause when you have done them. Okay, you should have, hopefully, I'm just checking out an answer there. Yeah, good. Right, you should have found the area. Remember, circumference is pi times diameter, but area is pi times by radius squared. So pi times by the radius, in this case it is 3. Now remember, I think it's a good idea to actually put R and D on these. This is only from the centre to the outside, so it's a radius. The diameter would be twice that. I always think it's a really good idea to write both down when you're doing a question, so it gets you thinking about whether they've given you a radius or a diameter. It's like this one, they gave me a diameter, so I need to know what the radius is, which in this case would be 3.5. This one, that is the radius at 6.5 because it's centre to the outside. The diameter, which is all the way across, would be 13. So I need to do pi times 3 squared, which is 9 pi. Just like we'd have 9 times x is 9x, we do 9 pi centimetres squared. Make sure you've got units there. See, didn't even need a calculator for that one. Now this one, yeah, to be fair, you have got a decimal in here, so you might need a calculator for that bit. But it's going to be pi times 3.5 squared. Now 3.5 squared is 12.25. And we want that much of pi. That times pi. Yep, easy. Centimetre squared. Just keep it in terms of pi. It keeps things accurate. Really accurate. Right, this time, pi times radius squared. So it's pi times 6.5 squared. Now 6.5 squared is 42.25. 42.25 lots of pi. 42.25 pi centimetre squared. Okay, remember, mark your work as well. Make it nice and clear that you've done so. Now that's going to be useful for today because what we're going to look at is cones. Now frustums, we'll come on to that, but it's something to do with cones, okay? So we're going to remind ourselves also of how to find the volume. So that's the space inside a 3D shape. And in this case, the 3D shape is a cone. Again, give your answer in terms of pi. Now here's some cones. We've got the radius on this one, and we've got the height. I've got a diameter here, but height on this one as well. Now that's because height is really important, because when you're working out the volume of a cone, it's a third times the area of the base times the height. So you need to find the area of the base first, so that's a circle. You then times it by the height and find a third of that, divide it by 3. Okay? Right. Pause the video, unpause when you've used that formula to find the volume of those 3 cones, please. Okay, again, this is stuff hopefully we've done before. Certainly if we're working on frustums, you need to have done this. So we want the volume of this one will be a third times by the area of the base. Now the area of the base is a circle, and that's pi times the radius squared, and that is the radius. It's centre to the outside. So pi times 5 squared times by the height. We don't want any slopey sides here. We just want the height. Well, there you go. So then we do that calculation. Put it in a calculator, see what you get. A third times by pi times by 5 squared times by 8. So it's a third of the area of the base times the height. And in terms of pi, that would be 200 pi over 3. And let's put that as a decimal as well, why not? 209. It does say give your answer in terms of pi, so that's what I'm looking for. In fact, it did say in terms of pi, so I'm going to leave it like that. You might have written it 200 over 3 pi. That is equally good as long as you've got your units, centimetres squared. But either way, it's 200 pi over 3. Good. Yeah, I'm not going to do decimals. It said don't do decimals, so I'm not going to do decimals. Right, centered to the outside of this one will be half of this. This is the diameter. So I need the radius, which is only half of that, which is 3.5. And again, volume. 1/3 times the area of the base. Well, that's pi times radius squared, so pi times 3.5 squared, times by the height, which is 10. Let's do that. 3.5 squared, oh sorry, the 1/3 times pi times by 3.5 squared times by 10. Just typing it in my calculator. Okay, and the calculator's done the fraction for me. 245 pi over 6. Or you might have done 245 over 6 pi centimetres squared, right? If you're confused by this, don't be. You are literally just using your formula, and your calculator will do all of that lovely fraction work for you. All right, I'm just getting you used to working out the volume of these cones. Now the cone, again, 1/3 times the area of the base. So that's pi times radius squared, because it's a circle, the base. So pi times 1.5 squared, because that is the radius, times by the height, which is 2. Do that again. So use your calculator. 1/3 times by pi times by radius, which is 1.5 squared, times by the 2 equals, that's a nice one, 3 pi over 2, or 3 over 2 pi centimetres squared. Cool. Let's just go and double check that one. It looks very much like, it looks a bit too easy, didn't it? So 1/3 times by pi times by 1.5 squared times by 2. Yeah, 3 over 2 pi. Nice. Okay. Right, let's have a look. What have we got next then? Now, a frustum. What is a frustum? Well, a frustum is a cone with the top removed, right? So we've basically got a big cone and we take a smaller cone off the top. So it's just cut the top straight off a frustum. Straight off a cone, and it leaves a frustum. Right, how are we going to find the volume of this frustum then? Well, this is it. We're going to find the volume of the whole cone. Imagine where those dotted lines are on top, that actually we include all of that and get the whole cone, just like before. And then we're going to subtract the volume of the top cone. So just find the volume of the whole thing and take the cone off the top. Now these two cones are mathematically similar. One is an enlargement of the other, because you're going to have the same angle in the top of this cone here. So actually, as you bring it down, and this plane, as we call it, so this flat bit is parallel to this flat bit. So they are mathematically similar, and that's going to be useful in a minute. Now let's find the volume of the whole cone. That's pretty straightforward. Use the formula, 1/3 times by the area of the base, and that is pi times by, this is a radius we got down here, so I'm going to use that, pi times radius squared, times by the height, which is 10. And let's see what that gives us then. So, and again, in the calculator, 1/3 times by pi times by 4 squared, oops, times by 10, which is the height. I've got, I'm going to keep it in terms of pi, right, because this makes things a bit easier. 160 pi over 3, and that's centimetres squared. Now, what about the volume of the top cone? So I'm going to do 1/3 times the area of that base of the top cone. That's the top bit there. Well, that's 1/3. In fact, I'm going to tell you what, just makes things really clear. I'm going to do this bit in a slightly different colour, because that might help you think. So 1/3 times by the area of the base, and the base is this bit here of this top cone, isn't it? That's the top cone. So pi times radius squared. Well, what's, oh, hang on, there's no radius. There's no measurement. Well, this one was 4, and this one is that. Well, oh, hold on, let's go back. They're mathematically similar though, aren't they? So I need my length scale factor, my ordinary length scale factor. And I'm going to do that from these two heights. the height of the large cone divided by the height of the small cone, which is 2. So the big cone has lengths which are twice as long as the small cone. Now I'm going to go from the big cone to the small cone when we're talking about this radius here. So I'm going to use my scale factor in reverse. So I'm going to divide by 2. So 4 centimeters divided by 2 is 2 centimeters. So this radius is 2 centimeters. And I use my scale factors, my length scale factor, to do it. In fact, I could, of course, use my volume scale factors to scale down the volume, but let's just stick to this for now. So 1/3 times the area of the base, so pi times 2 squared, and then times that by the height, that is times in there, times by the 5, which is the height of this top cone. I'm just finding the volume of the top cone, and I'm going to get my calculator to do all the work for me. So pi times 2 squared times by 5 equals 20 pi over 3, or 20 over 3 pi centimeters squared. So to answer the actual question, the volume of the frustum is the volume of the whole cone, so 160 pi over 3, take away the volume of the small cone. Now look how easy that calculation is, because I kept it in terms of pi, kept it as a fraction. It makes it so much easier to work with that. So minus, let's do another fraction, so 20 pi over 3. So 160 pi, take away, oops, 20, I'm trouble with my calculator here, times, take away 20 pi over 3, get the calculator to do it, and it says the answer is 140 pi over 3 centimeters squared. And I would, now you've got that answer, it didn't say do it in terms of pi, so I'm just going to turn it into a decimal. And because I've only done it as a decimal in the last place, it's going to be really accurate, much more accurate than it would have been before. And that's to 1 decimal place there. But this is the important bit, you know, that's completely accurate this in terms of pi. So find the volume of the whole cone, take away the volume of the top cone, and you're left with the frustum. Cool, have a go at that. If you are a bit stuck, maybe go back and reread it. Remember, find the volume of the whole cone, the volume of the top cone, and take one away from the other. Pause and unpause when you're done. If you're really stuck, go back and watch the previous explanation. Okay, unpause then. So volume of the whole cone. Let's do 1/3 times by, so this is, we need the area of the base, so that's pi times by the radius squared, so times 10 squared, and then we're going to times that by the height of 15. Put it in a calculator, see what you get. So 1/3 times by pi times by 10 squared times by 15 is 500 pi. Well, that's a lovely round answer. Centimeters squared. Look how easy that was. And the volume of the top cone. Let's change pen colors, because there's the base of my top cone there. And it's going to be 1/3 times the area of the base, so that's pi times the radius squared. No radius again, but they are mathematically similar cones. So let's use the lengths of the main height and the small height to give us a scale factor of 5, right? So the large cone has lengths which are 5 times bigger. Now I'm going in reverse, because I'm going from the radius of the big cone to the radius of the small cone, so I use it in reverse. I'm going to divide by my scale factor instead. Now 10 divided by my scale factor of 5 is 2. So my radius here must be 2 centimeters. So 2 squared times by the height of the small cone, which is 3, which I can already see is going to be 4 pi. But because I'm a little paranoid, I'm just going to just check it out on my calculator. Times 2 squared times by the 3 is, of course, 4 pi. I should have trusted myself. So centimetre squared. So we've got the volume of the whole cone and the volume of the small cone. And what we want is the volume of the frustum. Bit of a weird word. So 500 pi, take away 4 pi, we'll leave 496 pi centimetres squared. So brilliant if you got that. Perfect answer. But you might have changed it into a decimal because, I don't know, you might have done. I mean, let's have a look. Which is to one decimal place, 12.6, or 12.57 if you did 2 decimal places, and so on. Yeah. Cool. Oh, I keep putting centimetres squared. It's centimetres cubed. Silly me. Well, I'm not going to go back and change that because that'd mean an awful lot of re-recording. Sorry, yeah, centimetres cubed because we're doing volume, aren't we? Oh dear, I sort of feel we should go back and have a look. Let's have a look back on the previous page. Did I put that before? I did. Sorry, everyone. These should be centimetres cubed because it's volume. I bet some people watching this going, well, it's making that big mistake. Okay. Anyway, let's move on. I'll remember it's cubed in the future. Right, another one for you to have a go at then. Off you go. Unpause when you're done. You've unpaused and so have I. So let's have a look. Right, first of all, the main big cone. What's the volume? 1/3 times by the area of the base. So that's pi times radius squared. So pi times 3 squared. Times by the height, which is 12. I think it's going to be 36 pi, but let's just double check. So 1/3 times pi times 3 squared times 12 is 36 pi. See, and that's centimetres cubed because we're talking volume, volume, volume. Oh dearie me. Must be late in the week. Right, then the area of the top cone. So there's the base of the top cone. 1/3 times the area of the base. So that's pi times radius squared. Oh, I don't know my radius, but they're mathematically similar. So let's use get the scale factor. Use my 2 heights to find this length scale factor. 12 divided by 4 is 3. So all the lengths on the big cone are 3 times bigger than the small one. Now I'm trying to find the radius of the small cone. So I'm going to use my scale factor in reverse and divide by it instead. Now 3 divided by my scale factor of 3 is 1. So the radius of my small cone is 1. So 1 squared times by the height of the small cone, which is 4. I think this is, well, I can see what this is going to be already. This is 4 pi over 3 centimetres cubed. Yeah, because you've got that third at the front, haven't you? 1/3 times by pi times 1 squared times by 4 is 4 pi over 3, or 4 over 3 pi. Either of those is fine. Then let's find the volume of the frustum, the bit at the bottom. So we'll do the volume of the whole cone, take away the volume of the small cone, and it leaves, let's put that in, 36 pi, take away 4 pi over 3 equals 104 pi over 3, or 104 over 3 pi centimetres cubed. Brilliant, perfect answer, but as a decimal, 1 decimal place I'm going to go for 108.9 centimetres cubed. Less accurate than this one, but equally correct. Cool. Okay, similar question, but slightly different, because things do get a little bit harder here. Now again, we're going to find the volume of the whole cone, so we're going to pretend that there's a little bit on top of there, find the volume of the whole cone, and then subtract the volume of the top cone. And we know the 2 cones will be mathematically similar. So the volume of the whole cone. So I'm going to do 1/3 times by the area of the base. Now this is my base here, isn't it? Oh, not with the top cone. I want the whole cone. Oh dear, made another mistake. 2 in one lifetime. Weird. So 1/3 times by pi times by the radius, which is 8, and the squared, so pi times radius squared, times by the height. Ah, I don't know the height of my whole cone. So I need to find that out. But they are mathematically similar, these cones. Now, we're going to use this in a slightly different way. I mean, I could get my scale factor, but the problem is I haven't got the height of either the whole cone or the small cone. All I've got is the height of the frustum bit. So this is what I'm actually going to do. I'm going to use my mathematically similar cones in a slightly different way. The ratios of the height divided by the radius will be equal. So the height of the big cone, I'll tell you what, we're going to need to add a little bit of extra height on here to get the height of the whole cone. Now from the bottom to the top of the whole cone, the height is x plus 3. That's the height of the whole one. And its radius of the big cone is 8. And what about the height of the small cone? Well, the height of the small cone I've said is x, and its radius is 2. Right, so all I've done here, let's recap. I've said, well, to get the height of the full cone, I need to add on an extra bit. And I'm just going to call that x for now, and I'm going to find out what it is in a minute. So x plus 3 is the height of the whole cone, from bottom to top, plus 8. And the height of the small cone, the bit on top, is just x on its own, and divide that by its radius. Now, because these are mathematically similar, these two fractions will be equal. So all I have to do now is solve those two fractions. Right? Now I'm going to write them just a little bit neater over here, because it will give me more space to work. Okay. Now, let's find out what x is. We are going to solve it. Well, I'm going to times both sides by 8, first of all. And that will give me, well, 8 times this side is going to cancel out that fraction. Okay, so on this side, I will just have x plus 3. That's why I times it by 8 to get rid of the fraction. But this side will be times by 8, which will be 8x over 2. And then now I could, of course, just divide this side, couldn't I? I don't even need to times through by 2. Actually, I can just simplify this side. 8 divided by 2 is 4. Actually, I don't know why I changed pen colour there. So, actually, this means this equals 4x, because 8 divided by 2 is 4. It's just doing some basic solving here. Then, this is really bad. I'm running out of space all over the place. It's troubles of working on screen. The next thing to do would be divide by the number. No. I'm then going to take away x from both sides. And that will give me 3x over here. Sorry, let's write that in as well. Take away x. Obviously, it cancels out that x over there. So 3 equals 3x. Divide by that number touching the letter to show that x is equal to 1. I don't know if you heard that. Alexa just joined in then. X is equal to 1. So the height of the small cone is 1. The height of the whole cone is 4. Now, if you weren't sure about that, it was a slightly rambling explanation. Do go back and listen to it again. We just used, we put well, just go back and listen if you're not sure. Otherwise, let's carry on. So 1 divided by 3, sorry, 1/3 times by pi times 8 squared times by 4. Keep it as a fraction because it makes things a bit easier. 256 divided by 3, or sorry, 256 pi divided by 3 centimeters cubed. Volume of the top cone, that's nice and easy now as well. 1/3 times by the area of the base of the top cone, that bit there, which is pi times 2 squared, pi times radius squared, times by its height. Now the height of the top cone is only 1. So when we've done some of that, we will find it's 4 pi over 3, or 4 over 3 pi if you like. Cool. Then the volume of the frustum will be the volume of the big cone, take away the volume of the small cone. None of that is any different to what you've done before. Oops, 256 pi over 3. Take away 4 pi over 3 equals 84 pi. Is that really true? It is. That's very cool. The fraction disappears. 84 pi. Sort of really excited by that. That's amazing. So 84 pi centimeters cubed, or if you've turned it into a decimal, 263.9. 263.9 centimeters cubed. Either of those are correct, but the first one's more accurate. Okay, right after that, let's try this. Try this one, okay? Find the volume of the whole cone, volume of the top. You need to set up these little bits. So I'll kind of give you a bit of a head start. You're trying to find, obviously, the height of the whole cone. So we'll need to add a bit on to get to the top, which is x. Set up these fractions of the height of each cone divided by its radius, and then unpause when you're done. I've unpaused. Oh, let's go back on that. Right. I know I'm going to need this, so let's use this mathematically similar thing first and set up these two ratios, these two fractions of the height of each cone divided by its radius. Now the height of the big cone is x plus 5. That's the whole height divided by its radius, which is 8. And that's going to be equal to the height of the small cone, which is just x, divided by its radius, which is 4. Okay, right, let's do a bit of solving. Let's first of all, let's change my colour on my pen. I'm going to times both sides by 8, which will cancel out that fraction there. I'm just going to write the answer over here. So that's x plus 5 equals 8x over 4. And then, of course, we can simplify this side because 8 divided by 4 is 2. So x plus 5 equals 2. And then I'm going to take away x from both sides to get 5 equals now 1x, so just x. So x equals 5. So that top bit there is also 5. Both heights here are sort of both sections of 5, right? So 1/3, the whole volume of the whole cone, 1/3 times the area of its base, so pi times radius squared, pi times 8 squared, times by the height, and that's 10 because it's the whole height of the big cone. And I don't even need a calculator for that. That's 640 pi over 3 centimeters cubed. And then the volume of the top cone will be 1/3 times the area of its base. Remember, its base is this circle here, so that's pi times the radius squared, so pi times 4 squared, times by its height, which is 5. And I'm putting that in a calculator now. That is 80 pi over 3 centimeters cubed, because it's volume. Remember, only an idiot would forget to put centimeters cubed. Right, so then lastly, the volume of the frustum will be the volume of the large cone, so 640 pi over 3. Take away the volume of the small cone, which is 80 pi over 3, which is let's put that in. Put it in a calculator. Let's find out because I can use it for the decimal then as well. So 640 pi over 3. Take away 80. No, hold on, calculator. Let's make sure that's two fractions, two separate ones. So 80 pi over 3 equals 560 pi over 3 centimeters cubed. Ta-da! But as a decimal, just a one decimal place, 586.4 centimeters cubed. Cool. I hope you're getting the idea of that. They take a little while to get your head round. We're going to do a couple more, and then we're done, right? So another one. Unpause when you're done. You have unpaused. Remember, let's find out this extra height that we need. So we need an extra bit on top. That's x. So the height would be x plus 6 for the whole height of the whole cone, divided by its radius, which is 6. And that will be equal to the height of the small cone, which is just x, divided by its radius, which is 4. And let's do a bit of solving. Let's times both sides by 6. That will get rid of this bit of the fraction, which is, so now x plus 6 on the left hand side. The right hand side is now 6x over 4. Now this time it's a little bit harder to deal with that. I can't just divide this because I'll have like 3 over 2. So I'm going to times by 4 on both sides. If you got stuck at that point, now is the time to have a look at the answer for this and then to pause it again. Now that will cancel out the 4. So 6x is 4x plus 24. Take away 4x from both sides to leave 24 equals 2x. And then it's not much of a stretch to see, divide that by 2 to get x is 12. So the height of the top bit is 12 centimeters, so the whole height is 18. Volume of the top cone, 1/3 times pi times 6 squared, because that's the area of the base, pi times radius squared, times the height of 18, which is the mixture of 12 and 6. Okay, then, where are we? Let's go for, let's work that out. I think it's 216 pi, but I'm definitely going to put this one in a calculator just to check. So 1/3 times by pi times by 6 squared times by 18 is 216 pi. Why don't I just trust my own instincts there? Right, top cone, 1/3 times the area of its base. Remember, its base is that circle. So pi times by radius squared, pi times 4 squared, times by its height, and its height is 12. And this is going to be 64 pi, but guess what? I'm still going to put it in a calculator just to check. 1/3 times by pi times by 4 squared times by 12 is 64 pi. I just don't understand why I don't trust myself enough just to write it down. Right, volume then of the frustum is 216 pi. Take away 64 pi and see what's left over, which is 152 pi centimeters cubed, because it's volume, but as a decimal, 477.5 centimeters cubed. Ta-da! Correct. Oh, do you know, there's me saying there's only one more. It's actually 2 more. This one, another one. All right. Okay, pause, unpause when you're done. You'll get loads of practice at these. It'd be great. Okay, we've unpaused. Let's go for it again. Remember, let's set up these little ratios, these little fractions that are equal. We'll add the extra height on here, which we'll call x. And let's go, sorry, the height of the main cone is x plus 5 over its radius, which is 8. And that is the same as x is the height of the small cone divided by its radius, which is 3. Okay, now what we're going to do here, I'm going to speed things up a little bit and just show you a little neat trick. Now, if I times both sides by 8, that will cancel out that. And if I times both sides by 3, That will cancel out that fraction. So what I'm actually doing is timesing the top of the right-hand side by 8. Hang on, let's get a pen on this. Right-hand side by 8, so 8x. And the left-hand side I'm timesing by the 3. It's kind of like this sort of cross-multiplying thing to get rid of the bottom of this fraction, okay? And so times that by 3, you get 3x plus 15, because you times both bits by 3. Okay, neat little trick that. Then I'm going to take away the 3x from both sides to get 15 equals 5x, and then divide it by the 5 to get x equals 3. So the top part has a height of 3. Okay, let's get going then. Volume of the whole cone is 1/3 times by pi times by the radius squared, which is 8, times by the height of the whole thing, which is also 8, because it's 3 and 5 together. I can't remember what 8 squared. Oh, it's 256. This is going to. I know what this is going to be. I'm going to write it down, then put it in my calculator. 256 pi over. Oh, is it 512? It's 512, isn't it? See, I know it's going to be 512, so I'm just going to double check it before I redraw it. 8 squared times by the 8 is, yeah, 512, not 256. I was 1 out on my power of 2. Sorry, you would have put that in a calculator though, and just put it straight in. 512 pi over 3 centimeters cubed. That's the volume of the whole cone. Volume of the top cone, 1/3 times by pi times by its radius squared, so 3 squared, times by the height of just the top bit, which is 3. Now that is going to be 9 pi. Now that I definitely know. Okay. And let's get going then. So the volume of the frustum is the volume of the top bit. Take away the volume of the small cone. Oh, not the top bit. It's the volume of the whole thing. Take away the volume of the small cone is what I'm trying to say there. Take away 9 pi equals 485. Yeah, 4. Let's put it down here. So that equals 485 pi over 3 centimeters cubed, which to one decimal place is 507.8 centimeters cubed. All right? Okay. Now, last one. This is the last one, I promise. Have a go at this one. Unpause when you're done. Okay, you are done. So remember, let's set up these little ratios. We're trying to find the height of the top bit. So we'll call that x. And the height of the whole cone would be x plus 8. And that would divide that by its radius of 9. That's going to be the same as the height of the small cone divided by its radius, which is 5. And we're going to do this neat little thing, aren't we, with some cross multiplying to get rid of these things. So this side will need to be times by 9, and this side will need to be times by 5. So we've got 5x plus 40 equals 9x. Take away the 5x from both sides. We get 40 equals 4x, and divide it by that 4. We get that x is 10. So x is 10 centimeters. Volume of the whole cone, 1/3 times by pi, you know the drill now, times by 9 squared, because that's its radius, times by the whole height. Now the whole height is 18. Now if I knew what 6 times 81 was, I'd be able to do this in my head, but I don't off the top of my head. So 1/3 times pi times by 9 squared times by the 18 equals 486 pi. Now the volume of the small one is 1/3 times pi times its radius, now that's 5, times by the height of the top bit, which is 10. So this is going to be 250 pi over 3, and of course both of these are centimeters cubed. Right, volume equals the volume of the whole cone, 486 pi, take away the volume of the top bit, which is 250 pi over 3. Let's put that in my calculator. Equals... interesting. 1,208 pi over 3 centimeters cubed. So that's perfect answer. And then let's go for a decimal, which is less perfect. It's 1265.0 to 1 decimal place centimeters cubed. Right? Okay. I hope all of that helped. It is a tricky subject, and there's a lot going on. There's lots of, a little bit of algebra, making up equations and solving equations with fractions. You might find that tricky. You might find using the formula tricky. You might remember finding the area of a circle tricky, pi times radius squared. You might not like working in these fractions, or all sorts of things that could go wrong. But let's try and find some positives in there, particularly if you did it really well. Excellent, because this is tricky stuff, all right? So you should be really pleased with yourself. If not, maybe listen to bits of it again, or just, try and get those working out marks. That's the thing. Okay, right, thanks. See you again. Bye-bye.